So, hello everyone. Thanks for organizing this great conference. My name is Titus, and I work at the German Federal Institute for Quality Assurance and Transparency in Healthcare. Quite a long name. And more specifically, I'm from the unit for medical biometry and statistics at that institute. And today I want to talk about how quality assurance in healthcare can profit from R. So the IQ TIG, which is the short abbreviation for our institutes, is the central institution in Germany for the statutory quality assurance in the healthcare system. And we are based in Berlin, and right now we are about 160 people, and the institute was founded in 2015, so we are quite new in the sector. So one of the things we do, just to give you an example, is we would care about a certain medical issue that could be in-hospital mortality due to community-acquired pneumonia, and then we'd like to know what is the general situation in Germany about that topic and how do individual hospitals perform. So in order to do that, what we do actually is on the next slide, and that's we issue a software specification for the data collection in the hospitals. And through this process of the software specification and the data collection, we get the patient data of all the over 250,000 cases annually of community-acquired pneumonia in Germany. So we had quite a lot of data also in other medical sectors available. And additionally, we have a quality indicator specification that contains computational rules that define what kind of numbers we compute from the data. These numbers are things we call quality indicators. And both of these specifications are available online on our website, so it's transparent what we are doing there. And from these two, the data and these computational rules, we can compute results. And these results are somehow important as such, but they consist in the process mostly a pre-screening step, because afterwards, using that results with some of the hospitals, a structured dialogue is started, so-called, to do the real quality assessment and improvement and improve the quality in healthcare in Germany. So that's an example of what we are doing. And to do all this, we make extensive usage of R. So at the Biometrics unit, we use it for ad hoc analysis of our data, for statistical methodologies and development, and for internal reporting tools, of course, but we really also use R in production, so we have packages for the automatical computation of our results. That amounts to about 21 million numbers in one run for our standard routine report, if we start that package, for example. And then we also use R to create nice plots with DDplot, like for each of our quality indicators, and even in some cases we provide one plot per hospital where the hospital can see their result and compare themselves to hospitals of, for example, the same size with the same number of cases in that quality indicator. So that's quite an extensive use of DDplot. And to do all this, so our general philosophy is can you please advance? Yeah. The statistical analysis in general is a team effort, and for us it's really important to do a lot of code review and automatic testing in our packages, but also to do independent proof calculation of results by another second person really independently, because the aim is always to maintain a very high quality of analysis and the published results, because what we do and what we compute there has immediate and important consequences in the German healthcare system. So to do all this, we set up a lot of internal infrastructure recently. So we have an internal package repository with about 10 actively used packages developed by several people. And we have an internal Shiny server that several people use to deploy apps that help us monitoring problems in our data or in the results. Like, for example, in these screenshots you see which is red or green, so you can see, oh, maybe if there's something red, we should check if something is going wrong. And but we also use R in external communication, so it's not only internal use of R. So the computational rules I was talking about for our about 280 quality indicators actually will be published as R code starting this year. So far we were publishing pseudocode. And these computational rules mostly amount to very simple Boolean expressions that you can see at the top of the slide, but they can also be much more complex R scripts or contain some special abstractions, as you can see on the bottom here, where we will provide code for these expressions, maybe in the form of an R package in the future when we publish that. And speaking about R package, we recently released our first R package. It's called IQ TIG PVCI. That's for p-values and confidence intervals, and it's an illustrative implementation for our methodologies that we use for hospital classification, so other stakeholders in the medical system in Germany can see and reconstruct how we classify hospitals provided they have a certain result. And this package is available on our website. You can download it there. The website is all in German, but the package and its documentation is in English, so there's really no need to be afraid to click the download link and try it out if you like. And because it's all a matter of transparency, of course, that package is licensed under the GPL. And actually, code from that package already exists, as you can see on the next slide now, in an official document called the Plan QI Directive. That's a juristic official healthcare document in Germany. And so in the pseudocode, we use a function from that package to say what we are computing, actually. So summing up, R supports us a lot in our mission to improve healthcare quality in Germany. And actually, it's a natural choice to use R because it enables us to be more transparent just by being open source. Thank you. If you have any questions, you can come up to me later.